Alright guys, we're going to finish up 2.4. Okay, so this will be the part 3 video. And we're going to look at finding the standard deviation for grouped data. And then we're going to look at what the coefficient of variation is and what it means, how it's useful. And it's very useful, by the way. So anyway, with grouped data, it's very similar to when we found the mean using grouped data. Okay, so this is the formula that you're going to use. So we're assuming this is a sample, and so that's why the denominator is n minus 1. So a lot of this is very similar, guys. You still need to know the mean. You're going to find those deviations. You're going to square each one. You're going to add them all up. Well, you're going to multiply each squared deviation by f, and then you're going to add them all up, and then divide by n minus 1, and then take the square root to find the standard deviation. Okay. All right. So what we have right here is a histogram. So this says the number of courses taught per semester by a random sample of university professors are shown in this histogram. Okay, so this is a sample. Okay, so the way you read this is because this first bar has a frequency of 4, that means that there were 4 professors that just taught one class. And then this second bar represents the fact that there were 16 professors that taught 2 classes. So the heights of these bars, just like with any histogram, represents the frequency. And then the actual data, your x values, are going to be 1, 2, 3, or 4. Now I want to point out that a lot of histograms, guys, the classes are not, they don't consist of just one number. They're actually a range of values. And in those instances, you would be using midpoint. Okay, but in this case, each class is just one number. All right, so my x values are going to be 1, 2, 3, and 4. And then we're going to record those corresponding frequencies. So there were 4 professors that taught just one class. There were 16 professors that taught 2 classes. 21 professors that taught 3, and then 15 professors that taught 4 classes. And then what we're going to do is we are going to, because we need to, in order to do this third column, we actually find the deviations from the mean, we need to find the mean. Okay, so the mean is essentially going to come from this next column. We're going to multiply each x value by the frequency, and then we're going to add all of these up and divide by the number of frequencies. This takes us back to the end of 2.3 when we were finding the mean for grouped data. So that's essentially what we're doing here. Okay. All right, so x times f, 1 times 4 is 4, 2 times 16 is 32, 3 times 21 is 63, 4 times 15 is 60, and if we add this up and divide by the number of frequencies, this will give us the mean, okay, or the average number of courses taught per semester, or at least for this particular semester, okay. All right, so let's see if we can add these up. This would be 126. This isn't, well, let me get the calculator. Okay, so 126 plus another 36. That's going to give us 162. So see, it's the sum of those, each data value times its corresponding frequency, and then we're going to divide this by, really what we're doing here is finding a weighted mean, the sum of the frequencies. So it's 162 divided by the sum of the frequencies, let's see, so this will be, well, this is going to be 36 right here, and then that's 20 more, so 56. So 162 divided by 56. And unfortunately, we don't get a nice number, okay? I would say, let's round this to about 2.9. Okay, so we're going to say roughly 2.9. In your homework, you're probably going to want to do it with a little bit more accuracy. In fact, I might make this 2.89. Okay. So this would be the average number of classes taught. So you can see that 2.89 would be about right here. Does that seem right? Alright, yeah, it actually wasn't right because I didn't add this column correctly. This should actually be 159. Okay, so and 59, and then we'll divide that by 56. And let's see what we get. So I guess I'm going to go, I'll round it to 2 decimal places. I'm going to go to 2.84. Okay, so it's a little less than what we had a second ago. Okay. Alright, so now what we actually need to do is we need to find these individual deviations. Okay, so this is the mean right here, or x bar, 2.84. So we need to take each x value and subtract from it 2.84. So I'll show this first one, 1 minus 2.84. That's going to be equal to a negative 1.84. The rest of these I think I'm going to do in my head. 2 minus 2.84 will be a negative 0.84. And then 3 minus 2.84 will be a 0.16. And 4 minus 2.84 will be 1.16. Okay. So now what we need to do is actually square these individual values. So now remember, when we square a negative, it always becomes a positive. So I could just put 1.84 in there and square it. And I'm going to round this to, I guess, 3 decimal places. So this would be 3.386. And then I'm going to square 0.84. Remember, you can ignore the negative because they're all going to become positives when we square them. And to 3 decimal places, this would be 0.706. And then if I square 0.16, this will be 3 decimal places, 0.026. And then finally 1.16 squared, and we get 1.346. Okay. Now what we're going to do is we're going to take each of these squared deviations and multiply by the frequency, and then we'll add all these up, okay, because that's what the formula says. We need to find the sum of this last column, and then we'll divide by n minus 1. Well, technically this should be the frequency minus 1, or the total frequency, which is the same thing as the sample size. Okay, so anyway, all right. So, well, the first one, this times the frequency of 4. This is why Excel's a lot better, guys, because Excel will churn out these tables. And this would be 13.544. 0.706 times that corresponding frequency of 16, and we're going to get 11.296, and then 0.026 times that corresponding frequency of 21, and we obtain 0.546. And then finally, 1.346 times the frequency of 15, and we get 20.19. Okay. So now what I need to do is add up. I need to find the sum in this column. So I'm just going to use that previous value and say plus, and we'll type in the rest of these. $296 plus that last one, 13.544, and we get a sum of, we'll say, 45.576. Yeah. Okay. And so now what we need to do is we will take that value, 45.576, we'll divide it by the total frequency minus 1, where the total frequency is 56, so 56 minus 1 would be 55. I'm just going to do all this in my calculator. And remember, to get the standard deviation, it's going to be the square root of this. Alright, so let me divide this by 55, and then I'm going to take the square root of that number. And I'm getting 0.91 roughly. Okay. So this would be equal to S. Now I want to point out, guys, this, the way I've done it here using a table by hand, this is really not the best way to do it, because when I start truncating digits way back in this column, each operation that I use, I lose accuracy. I've lost some accuracy here. I lose some more accuracy. Okay? So if you're any good at Excel, what you can do is, you can list your data values, then you can list the corresponding frequencies, and then these new columns, you can tell Excel what to do. You can tell it to multiply X and F to get this new column, and then subtract the mean from everything that's in this first column, and it'll give you this fourth column. Okay, so Excel is very powerful in that way, using the formulas and stuff. But anyway, all right, so the standard deviation here is it's close to 1. So we could say that, well, this is not perfectly symmetrical or bell-shaped, but if it were, we could say that, roughly 68% of all professors would have taught, whatever the mean is, give or take the standard deviation. But anyway, all right, so there's an example with grouped data. And again, let me point out this last bullet right here. If each group consists of a range of values, then you're going to use the midpoint for that group. Okay. So in this case, each class was just an individual number, just a single number. It wasn't like a range. All right, let's go on and look at this last subsection, okay, of 2.4. So the last thing is called the coefficient of variation. And guys, this is very important. It's typically abbreviated with capital C, capital V. It allows us to actually compare the variation of two different data sets. Okay. because you could have two different data sets. So for example, let's look at these two right here. You could have a sample of heights and then another sample of the corresponding weights of these individuals. You could find the mean and the standard deviation of each of these data sets, and I would be willing to bet that the standard deviation for the weights is going to be bigger. And one of the reasons is simply because these numbers are larger. Okay, so they could more or less have the same distribution, but the standard deviation is probably going to look bigger simply because these weights are larger numbers. So when you're comparing the variation in two different data sets, you need a reference point. Okay, and that reference point is essentially the mean. How does the standard deviation for one data set compare to the actual mean of that data set? That's what the coefficient of variation is. Okay, it's the standard deviation as a percentage of the mean. And so once you know the coefficient of variation for two different data sets, then you can definitively say whether the data is more dispersed in one data set as opposed to another. Okay, so you can't just do that by comparing the two standard deviations, because the nature of the data could be completely different. The one with the larger standard deviation might actually be much tighter, a much tighter distribution. So anyway, and so you can see here, this is essentially how we do it. Of course, if you have a population, then you're going to be using sigma and mu. Okay, so sigma, again, remember, this is the Greek letter that we use to denote the standard deviation of a population, divided by mu, which is the Greek letter that we use to denote the mean of a population. Okay, so it's the standard deviation divided by the mean. And then to make it a percent, you multiply it by 100. And then for a sample, it's just very similar, except you're using S instead of sigma, and you're dividing that by x bar instead of mu, and you're still going to multiply by 100%. All right, so let's look at an example here. So what we want to do, it says the height in inches and weights in pounds of 10 adult males is given in the table below. Okay, so we want to calculate the coefficient of variation for each data set. And then what conclusion can you make about the variation of heights versus weights of the mean? Okay. So for this, I'm going to use Excel. Guys, you can use your calculator, that's perfectly fine. You know, you'll have to enter your data in one list and then click the one variable statistics, and it'll give you both the mean and the standard deviation. I just personally like Excel better. Okay, so you can see I've actually already got the data in here. Okay, so what I'm going to do is I'm going to let this cell right here, I want this cell to be the mean from this first data set. Okay, so I'm going to say equals, and then I'm going to come over here. Now, if it's one of these functions I've already used, like average, I can just click it. And then remember, I'm going to select the cells that contain the data that I want average, so it'll be these. And I'll click OK. And then what I'm going to do is I'm going to come over here in this next cell, and I'm going to let this be the mean for my second set of data. Okay, so I'm going to say equals, and average is, well, I'll go ahead and click average again. I'm going to drag this second column, click OK, and this is now the mean of these different weights. Okay. All right, so now I need to find the standard deviation. Well, similarly, I'm going to go to this cell below the mean from my data of weights, and I'm going to say equals, and I'm going to find standard deviation. It's one I've already used, but well, no, it's not, because we're talking about a sample and not a population, right? So let's come over here to more functions, and let's scroll down to the S's for standard deviation. And let's use this one. It's got to be standard deviation.s because we're talking about a sample here. I'll click OK. I'm going to drag these same cells and click OK. And now that's the standard deviation for the weights. And then let's do the same thing, or excuse me, I said that backwards. This is the standard deviation for the heights. And then we'll do the same thing for the weights. Okay, so I'm going to say equals. Standard deviation's already there. I'll just click on it and I'll highlight my second set of data. Click OK. And this is the standard deviation for my second set. So you'll be looking here and you'll say, oh, okay, well, clearly the standard deviation for these weights is greater than the heights. But with respect to the mean, how does it compare? And that's what we're going to find next. Okay, that's that coefficient of variation. And I'm going to put in here that I used either the calculator or Excel to find these. So let's find the coefficient of variation for the heights first. So it will be S over X bar. Alright, so the standard deviation for the heights is 4.33 divided by X bar, which is 70.75. And I'll just use my calculator for this, although you could still use Excel. So 4.33 divided by 70.75, and we're going to get, let's go to 4 decimal places, 0.0612. Okay. And if we multiply this by 100, this is going to become 6.12%. Alright, so now let's do the same thing with the weights. Okay, again it's going to be S over X bar. So the standard deviation for the weights is 22.96, 2 decimal places. Divided by X bar, the mean, 192.75 pounds. Let's see what this is. Okay, so 0.1191. We multiply this by 100, we're going to get 11.91%. Okay. All right, so now we can actually say which data set has more variation, and it's going to be the weights. Okay, so it's just kind of coincidental that yes, the weights did have the larger standard deviation, and there is actually more variation in this data set. Okay. With respect to the mean as a percentage of the mean. So anyway, that's very important, okay, anytime you're dealing with 2 different data sets. Alright, well that is the last one, and this is just a summary of some of the things that you can do in the calculator. Okay, like I said, you know, you can find all of this information in the calculator. We've done that before. But anyway, alright guys, well I will see you in 2.5, which will be our last section of this chapter on descriptive statistics.